Well, hello again, my friends. Welcome to another math lesson with Mr. Kalashin. Today's lesson is day 103, Fractional Patterns. And it can be found on page 321 in your Volume 2 Math Notebook. As you can see, you'll need your math notebook, a pencil. If you have a whiteboard available, great, and a dry erase marker. If you don't, again, paper will do along with a pencil, but you need something to write with so that you can do some additional practice, just more than what's in the notebook itself, math notebook itself. And here we go. Learning objective. Today we will find and create fractional patterns. The standard is 5OA3. Essential questions. How are points located on a coordinate plane? And that's what we've been working with the last few lessons. Describe the pattern of each sequence. And you can tell we're in the math notebook now. And I know you're focused. I know you're going to pay attention. If I go too fast, the beauty of these lessons are you can pause it at any time, go back and replay it, freeze the frame, look at the screen, study what they have shown for you. It's real important that you make good notes in your math notebook so that when it's time to do your own work, you have something to go back on that's done accurately. Sequence X starts with 10, then 15, then 20, then 25. Sequence Y, 2, 3, 4, and 5. Pause now, see if you can answer that, and then hit play again, and we'll talk about the answer. Okay, so you're back, so I presume you've done the work. Let's see what we have here. What do you notice about the pattern in sequence X? Well, it starts with 10 and gets 5 larger each time. The rule is you add by 5. So pattern X starts with 10 and adds 5 each time. Sequence Y starts with 2 and adds 1 each time. Hopefully you got both of those on your own. Describe the pattern of each sequence. Sequence X, 8, 10, 12, 14. What do you notice about the pattern in sequence X? Pause again, answer on your own, and play it when you're ready. Okay, so we're back again. So I hope you got started with 8 and added 2. Pattern Y, or sequence Y, is 24, and from there you add a certain number each time. Again, hopefully you got 24 and add 6. And if you're not sure, you can just count up. Count up from 24 to 30. You should get 6. Count up from 30 to 36. You should get 6. Hopefully you can look at that and determine that it is 24 and add 6. Create 2 sequences of numbers that follow the given patterns. Pattern A, start with 1/2 and add 1/4 each time. Pattern B, start with 1/4 and add 1/4 each time. Well, let's do it together. Okay, there's sequence A. Starts with 1/2. You add 1/4. Well, wait a minute now. We have to have like denominators before we can add. We can't just throw those two numbers together. And how do we do that? We have to have common denominators. What could we use? Well, write this down, please. Please write this in your notebook. Please write this in your notebook. 1/2 times 1, 1/2 times 1/2 times something equals 4. Well, what would you multiply the 2 times to get 4? 2. Whatever you do to the denominator, you must do to the numerator. So it would be 2 over 2 times 1/2 equals 2/4. Please write this down in addition to what we're doing with the array. And 1/4, you just multiply a 1 times a 4. Whatever you do to the denominator, you must do to the numerator. So it would be 1/4. So 2/4 plus 1/4 because 1/2 is the same as 2/4, same value. 2/4 plus 1/4 is 3/4. And you remove the 1/4 there. Now 3/4 plus 1/4 is 4/4. We're just going to leave it like that for the time being, 4/4. And 4/4 plus 1/4 is, that's right, you guys are on it. You have been on it every time I've been teaching a lesson. You're right, it is 5/4. And we're going to just leave it like that for a second, but we'll come back to it. Sequence B, 1/4, and you add 1/4. This is a little more straightforward. No converting needs to be done. 1/4 plus 1/4 is 2/4, and then 3/4, and then 4/4. But now the question is, are there any values that could be simplified? Yes, there are. Take a look at that for a moment. Pause it. See what you come up with. How could you simplify those? How could you write some of those improper fractions as a proper whole number and fraction? So I'll ask you to pause it there, get your answers ready, and come back and we'll go over it. Okay, hopefully you've done that and you're back, and let's see what we have. So we have, let's come back to that. 4/4 is equal to 1 whole, and 5/4 would be equal to 1 and 1/4. 3/4 stands fine on its own. 1/2 stands fine on its own. But 4/4 should be 1. 5/4 should be 1 and 1/4. Let's jump down here to sequence B as well. 1/4 stands on its own. 2/4 would convert to 1/2. 3/4 stands on its own, and 4/4 would be what? Right again, 1 whole. So yours should look like that. Make sure you have that. You can pause this at any time and freeze it and make sure you have that written correctly. Any other thing you need to get in there. Let's continue. Create two sequences of numbers that follow this given pattern. Pattern A, start with 1/2 and add 1/3. Pattern B, start with 1/3 and add 1/3. Pattern B looks pretty straightforward. Pattern A, a little more work is required. We need to find common denominators. Well, wait a minute. Whoa, how did we get 6? Well, because 2 and 3, a common denominator for both would be 6. If you multiply 2 times 3, you get 6. 2 would go evenly into 6. 3 would go evenly into 6. So 6 is what we're looking for here. 1/2 plus 1/3. 1/2 is equal to 3/6. 1/2 is equal to 3/6. And 1/3 is equal to 2/6. So 3/6 plus 2/6 is 5/6. Let me say that one more time. 1/2 is equal to 3/6, and 1/3 is equal to 2/6. Because you have to multiply 3 times 2 to get 6. 1 times 2 is 2. 2 times 3 equals 6. 1 times 3 equals 3. Hopefully everybody's got that. So 3/6 plus 2/6 is 5/6. Then add another 1/3, which is 2/6. That would be 7/6. Add another 1/3, which would be 2/6, is 9/6. Here, sequence B is pretty straightforward. 1/3 plus 1/3 is 2/3, plus another third is 3/3, plus another third is 4/3. However, now we need to get these in. Remember, you can pause this at any time and take a look and make sure you have it copied down correctly. Now we have to convert them. So let's go back. 1/2 is fine. 5/6 is fine. 7/6. Oh, that should be. Pause it here. Get those converted correctly, simplified, reduced, written correctly, and then come back. Okay, hopefully you've done that now and you're back again. So 7/6 should be 1 1/6. 9/6 should be 1 3/6, but 1 3/6 really should be written as 1 1/2. 1/3 is fine. 2/3 is fine. 3/3 is what? You're right. You're right on. 1 whole, and 4/3 would be 1 1/3. And it should look like that. All right, let's continue on. You're doing a great job again, as usual, as always. All right, create two sequences of numbers that follow the given patterns. Pattern A, start with 1/2 and multiply by 1/3. Now we're multiplying. Boy, it's real important that we're paying very close attention to the directions as they're given. You can't miss that. Multiply. So 1/2 and multiply by 1/3. And here on pattern B, you start with 1/3 and multiply by 1/3. All right, let's continue. What are we going to do here? 1/2 times 1/3. Now let's think about this. What do you do when you multiply fractions? That's right. You multiply denominator times denominator and you get 6. You multiply numerator times numerator and you get 1. So 1/2 times 1/3 is 1/6. Let's just repeat the process. 1/6 times 1/3 is what? Oh, so many of you are way ahead of me. You already know that's 1/18 because you know 1 times 1 is 1 and 6 times 3 is 18. Okay, now we're getting into big kid math. 1/18 times 1/3. Well, the 1 times 1 is easy, but 18 times 3, I think maybe we're going to bring that down here and do it the old-fashioned standard algorithm way. 18 times 3. Here we go. 3 times 8 is 24. Bring down the 4, carry the 2. 3 times 1 is 3, plus 2 is 5. 54. So it would be 1/54. All right, now sequence B. Oh, let's answer this question first. Are our values getting larger or smaller, and why? Pause. Tell somebody. Find a parent, find an older brother or sister. Discuss it with them. Tell them, is it getting larger or smaller, and why? Come back to me and tell me. All right, you're back. Hopefully you had a chance to talk to somebody. Are they getting larger or smaller, and why? Right again, I hear voices coming back at me. I can hear you. Everybody, most people are telling me 1/54th, it's getting smaller. The value of each fraction is getting smaller because one piece out of 54, one part of 54 is much smaller than one part of 2. One part of 2 is much bigger than one part of 6. One part of 6 is bigger than one part of 18. One part of 18 is bigger than one part of 54. So as we continue down this path, the value of the number keeps getting smaller as we move further to the right. You are right on. All right, now let's take a look at sequence B. Sequence B is 1/3. 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1/27th. How do I get that? 3 times 9 is 27. 1 times 1 is 1. Oh, now we're in the big kid math realm again. 1/27th times 1/3. Well, let's do it the old standard algorithm way again. Don't try to do this in your head. Now, some of you might try it, but be careful. Be careful. Make sure. There's no rush on this. 3 times 7 is 21. Bring down the 1, carry the 2. 3 times 2 is 6, plus 2 is 8, 81. 1/81st, 1/81th, 1/81th, or 1/81st, 1/81th, 1/81st, well, whatever. So again, same value again. This is the largest fraction of the array. This is the greatest value, then less, then less, then least. This would be the smallest value of the 4. This would be the smallest value of the 4 here across the top. And of all of these fractions, the one that is the least value of any is this one right here. Okay? And the one that has the greatest value is this fraction right here. Okay? If all the numerators are the same, which they are, 1, then the one with the smallest denominator is the greatest value fraction. Okay? Let's continue. All right, to create two sequences of numbers that follow this pattern. Pattern A, start with 1/3 and multiply by 1/2. Pattern B, start with 1/4 and multiply by 1/2. I'm going to stop there. I'm going to ask you to pause. You fill it in. You fill that in now on a piece of paper or whiteboard, and then play again when you have it all filled out. All right. Hopefully you're back and you filled it all out, and let's see how you did. And there it is. There it is. Because you're multiplying it times a half. So that's 1/3 times a half. 1, 2 times 3 is 6. 2 times 6 is 12. 2 times 12 is 24. Here it's a half again. So 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. If you have any questions, hopefully there's somebody there that can help you. Or you can ask your teacher when you see them next or communicate with them next. But hopefully that's clear to everyone. Let's continue on. Describe the pattern for each sequence. Oh, now they've provided us a sequence, and we have to look at describe the pattern for each sequence. So we have a half here. Well, now it jumps to 7/10, 9/10, and 11/10. Now let's take a look at this one first. This one looks like it's a little less daunting. There's no conversion of denominator here. This looks pretty straightforward. It goes from 1/10 to 3/10 to 5/10 to 7/10. So what is the pattern here? You're right. You add 2/10 each time. 1/10 plus 2/10 is 3/10. 3/10 plus 2/10 is 5/10. 5/10 plus 2/10 is 7/10. For sequence A, it would be it's 1/2 plus 2/10, because 1/2 is equal to 5/10. 1/2 is equal to 5/10. 1 is half of 2, 5 is half of 10. So 1/2 equals 5/10. 5/10 plus 2/10 is 7/10. 7/10 plus 2/10 is 9/10. 9/10 plus 2/10 is 11/10. Now, how could we... oh, wait, there's another question down here we got to answer. How do you find a pattern when we used whole numbers? Well, you can subtract. You can subtract to determine... You can just subtract the smaller number from the larger number, determine what the difference was, and that becomes your pattern. Oh, well, 9 is, 9 minus 7 is 2. Well, okay, so I added 2 to 7 to get 9. I added 2 to 9 to get 11, etc. So that's how you would determine your pattern. How you would determine your pattern. You can use subtraction to determine that. What is necessary for us to call something a pattern? Well, for it to be necessary to call it a pattern, it has to be provable and repeatable. You have to see the same thing happening again and again and again, as we did here. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. If you see the same thing happening over and over and over again, that becomes a pattern. Equals 2/10, so 9/10 minus 7/10 equals 2/10. And that's how you prove what the rule is or how the sequence is being arranged, by using subtraction. Make sure you're writing all of this in. 7/10 minus a half. 7/10 minus 5/10 equals 2/10. Okay, so make sure you're getting all of this in. This is good support. Mr. Kalashin kind of told you the same thing, but I can't show you like this is showing you. It's difficult for me to write on the screen like that. Okay, pattern A starts with 1/2 and adds 2/10, which is what we just said. But make sure you're writing all of this in. Pause it if you have to. Copy all of this in your notebook, please. It's important support material. Adds 2/10 or 1/5. Pattern B starts with 7/10 minus 5/10 starts with 5/10 minus 3/10 equals 2/10. 3/10 minus 1/10 equals 2/10. So pattern B starts with 1/10 and adds 2/10 or 1/5. Please make sure you have all of that material written in. They're proving the pattern here. They're proving the pattern. They're proving that 7/10 minus 5/10 is 2/10. 5/10 minus 3/10 is 2/10. 3/10 minus 1/10 is 2/10. So it's 2/10, 2/10, 2/10. The fraction's either getting smaller by 2/10 each time or getting larger by 2/10 each time, depending upon which way you're moving on the sequence. So they're proving the reliability of that pattern. That's what you have to do. So please make sure you have that written in to satisfy yourself that you've proved the pattern beyond a shadow of a doubt. Describe the pattern for each sequence. Sequence A, 1/2, 2/3, 5/6, 1. Sequence B, 1/3, 1/2, 2/3, 5/6. What is necessary for us to call something a pattern? It has to continue on and on and on in the same way. So pause here, see what you come up with. Pattern A starts with what and what is the rule? Pattern B starts with what and what is the pattern or rule? Pause here, answer that, and then come back and we'll discuss. Okay, so you're back, and the answer is pattern A starts with a half, of course, that's straightforward, and adds 1/6. Pattern B starts with 1/3, again, straightforward, and adds 1/6. How do we know that? Because 1/2, 2/3, so 2/3 is 4/6. 1/2 is 3/6. So this would be 3/6, converting 1/2, because you have to convert to common denominators, and 2 and 3 have a common denominator of 6. Okay, so 3/6 plus 1/6 is 4/6. And 4/6 is the same as 2/3 because 2 times 3 is 6 and 2 times 2 is 4. Then 4/6 plus 1/6 is 5/6, and 5/6 plus 1/6 is 1 whole. On sequence B, 1/3 add 1/6. Well, 1/3 is equal to 2/6 because 2 times 3 is 6, 2 times 1 is 2. Remember, whatever you do to the denominator, you have to do to the numerator. 2 times 3 is 6, 2 times 1 is 2, 2/6. 2/6 times 2/6 plus 1/6 is equal to 3/6, which is 1/2. 3/6 plus 1/6 is 4/6. 4/6 is equal to 2/3. And 4/6 plus 1/6 is 5/6. Okay? Hopefully you got that. Hopefully you got that. Let me write in here. That would be 4/6, and you're just converting it. So 2/3 is 4/6. 1/3 is 3/6. So you see you have to convert back and forth. So 1/3 is 2/6, 2/6, add 1, 3/6, add 1, 4/6, add 1, 5/6. Okay? Just have to convert it back and forth. You're good at that. You understand how to do that. Hopefully there are no questions on that. Pause it, look at it if you have to, and think about it. Let's continue. Closure. Describe the pattern for each sequence. Sequence X, sequence Y. Okay? Pause it here. Do the work, and then come back to me when you're finished. Okay, you're back, and hopefully you got it. So we started with 1/2, and 1/2 plus what equals 1? You're right, 1/2. So this would be 1/2 plus 1/2 equals 1. And 1 plus what? 1/2 equals 1.5. So here would be begin with a half and add a half each time, because 1/2 plus 1/2 equals 1. 1 plus 1/2 equals 1.5. Here we have 1/4, 3/4, 1 and 1/4. Well, this is pretty straightforward because the denominators remain the same, fourths, and the numerator, 1 to 3, that would be plus 2/4. So 1/4 plus 2/4 is 3/4, and 3/4. Now, how could we write 1 1/4 in improper fractions? We could write it as 5/4, because 1 whole is 4/4, and add 1 and it's 5/4. Well, so it becomes pretty clear that 3/4 plus 2/4 equals 5/4, or correctly written 1 and 1/4. So hopefully you understand that. Hopefully you have it. Hopefully there are not too many questions. Hopefully this was clear to you. I enjoyed presenting it to you. I hope you enjoyed it being presented to you. You guys did a great job as always, and we'll see you next time.